Hello everyone, this is me Kalam Hussein here, and I'm going to present up my uh, 14th practicum of computer organization and architecture. So let us dive into it. The for Basically, let us start from the procedure itself. So the first step is here to execute both CPU and GPU operations for comparison, and in the second step, we got to accept the required values such as vector size and input data, both are from arrays A and B respectively. And on to the third step, which is validate the inputs for correct numeric format and ensure compatibility with the selected execution mode on the NVIDIA Jetson Nano. And on to the fourth step, which is to perform vector subtraction and division using the selected mode, which is basically from CPU, which is numpy and QPY from GPU, and display the computed output vectors and execution type clearly in the console, and allow the user to repeat the steps with the different input sizes, which can be used for comparison. And after that, terminate the program when the user is requires to exit. And let us dive into the steps. The first step here is to boot Jetson Nano, insert SD card with Jetpack SDK, and power on the and complete initial setup. And after that, on to step two, which is install required libraries, open terminal, and type this three required libraries: sudo apt update pip3 install numpy pip3 install cupy slash CUDA11X. And after that, create a program. And after that, import the libraries here. And the size of this is basically 10 to the power of 6. And after that, we got to import the values of A and B respectively for CPU. And the start is equal to time dot time. Subtraction in CPU is equal to CPU minus B CPU, and division CPU is equal to A by B CPU, and the CPU time is equal to time dot time minus start. And after that, respectively for the up it applies for GPU respectively. But there's a small catch here. As you can see, after here, you can see the notable difference here. uh, cp.cuda.st stream dot null synchronize has been used here. And after that, you could see the steps which are similar to this. And after that, in step 4, we got a print. Uh, on in step 4, you got to print this and run the program. And after that, you got to input the values, sample, basically sample inputs, and the outputs will be arrived. And as you can see, both the outputs are similar. And thus, here's the catch. As you can see, in CPU time, you can see that it's showing 0.00050, whereas in GPU time you can see that 0.0032. So what they are trying to say is that GPU process happens quicker than comparatively to CPU, as GPU handles multiple execution so easily. And let us dive into this here. This is also a basic sample here. As you can see, I derived a value from here. And as you can see, this is the same code which I applied here, but but I have applied a few different input values. And as you can see, I tried the same method, as you can see. And in CPU time, there's a no there's this value. The time occurred here is 0.003368, and so on. Whereas in GPU time, you can see 0.00090. So this stuff appears to be, uh, as you can see, GPU time takes lesser time, whereas in CPU time, the process has to be taking more amount of time. And overall, CPU time can't overbeat GPU. And that's it. And thank you.